Welcome to qnawire.
Question 74 states that a person holding a lunch bag is moving upward in a hot air balloon at a constant speed of 7 meters per second. When the balloon is 24 meters above the ground, she accidentally releases the bag. What is the speed of the bag just before it reaches the ground? So a question like this would benefit from a diagram. So we have the hot air balloon, we have a person sitting in the basket, or I'm not sure exactly what you call that. This is our balloon. Looks like a light bulb. I'm not a good drawer, obviously. But we're at a height. But say when the person drops the bag, this height here, I'll call the distance, is value d. If this is my bag here, my lunchbox, it gets dropped and falls downward. However, the initial velocity of the bag and the system, the balloon as a whole, is given by v naught upward. So for this problem, the first thing I'll do is establish my positive direction, which I'll call upward to be positive. Okay, so in this problem, we want to find the final velocity of this bag as it hits the ground. Right, so in this scenario, if I just look at what I'm given, the equation I want to use is v equals v naught. V naught here is positive because this is going upward, but my g is negative because it's going towards the ground, times t. I know my v naught, I know g, I don't know t. So while this is the one I want to use because I want to solve for v, I need to recognize that I need a kinematic equation to help me find t. So I look at my other one, the distance, the height equals v naught t. Again, this time it's minus 1/2 gt squared. Or again, if you want to look at signs here, technically, no, actually we're fine as is. Yeah, no, we're okay. Okay, sorry. Gt squared, right. Yes, I did make a bit of a mistake here. This is actually negative d because I'm going from a higher height down to a lower height. So this d should be negative because I'm falling, again, towards the negative direction. Great. So I can rearrange this equation, and it should look somewhat noticeable. If I have 7t, actually I'll plug in that value as well. I just plug my values just so it's a little more obvious, perhaps. 24 meters, positive here, of course, because it was negative on the other side, plus 7.0t minus g over 2 times t squared. This is a quadratic formula in which you can solve. I use it in Excel. Use whatever you like. I'm not going to show how to solve a quadratic formula here. Just recognize that this is one, which I'll call QF. And by doing that, you get two solutions, one being a positive value, one being negative. The negative in this case doesn't make sense. Not physically a reasonable answer. So we take the positive root to be 3.03 seconds. So now if we go over here and we put that into our equation, which I guess looking back again, this should be negative as well because the velocity as it hits the ground will be going downward. So we can find that our velocity is simply our negative v naught minus gt. Again, taking into account the negative, what's negative 24 minus 9.8 times 3.03. And we solve for this and we find that our final velocity is negative 22.7 meters per second. There you go. One slight mistake. While the answer I gave was correct, I actually put in my distance value, not initial velocity. So this should be, 7. Our initial velocity given to us, 7.0 minus 9.8 times 3.03. Which I guess if we should round this to two significant digits, to be negative 23 meters per second.